So in this video, we're going to talk about the translations of sine and cosine, or the shifting of sine and cosine graphs, and specifically horizontal translations. Well, I want you to kind of think back to perhaps college algebra or somewhere back, maybe algebra 2, when you learned about the translation of a function. These values might look familiar to you, or these letters. Remember that if we have some function where this is my function, in this case I'm looking at an x squared function or a quadratic function, and if I have a minus h on the inside here, I had a k on the outside, I had this a in the front and a negative sign. Well, we learned, when you have learned previously, that when we have these things going on with our function, then it tells us certain ideas about what our graph is doing. For example, anytime that there's a negative sign in front of this value of a, then we're talking about it reflecting or flipping across the y-axis. In our translations, we also learned that this a for us in this function was to shrink it or stretch it. We also had a number inside of the parentheses here. This number stood for a horizontal shift. In other words, it was going to move left or right, and it was never the same sign as what it appears. So if we were looking at this function right here, then this would have a shift to the right. Okay, it would have a shift to the right, whatever that value was. The last thing that we might remember is that if I'm adding a number to my function, then I had a vertical shift. So that's what it would look like on functions in general, but let's look at this specifically relating to trig functions. Here I'm showing you the sine function, and it's going to be the same. We have all of these values that would be the same for us if we were talking about any of the other 5 functions, where we know that a for us in this case stands for the amplitude. Remember, that's the value along the y-axis. That would be also like our range. And then if we have a negative amplitude, or this negative sign in front of my a, then we are going to again just reflect across the x-axis. We also have here a shift, okay, where this is inside of the parentheses with the variable x. Okay, so if I have a horizontal, we call this a horizontal shift. In trig, or in trig, we call these phase shifts. So a phase shift is technically a horizontal shift left or right. We have the period of the function. Remember, this tells us how many complete pictures we have. Then we have, last but not least, the vertical shift. So these have different values, different letters, as opposed to what we just looked up above, but it's the same concept as what you know originally from when you translated functions. So let's see, with this first example, what happens when I take a graph and I shift it horizontally, or in other words, I do a phase shift. So this is the first example. Y is equal to the sine of x minus pi over 3. And I want to graph this for one period. The first method I'm going to show you is using the table method. And when we look at this function, we initially need to determine, well, what is the length of my interval? Or in other words, what is the period for sine? The period for sine, if you remember, is between 0 and 2 pi. So I know that a normal sine picture occurs between 0 and 2 pi. Well, I'm shifting this graph, and I am going to be shifting this by some pi over 3. So I'm going to be changing my interval. Since I'm shifting this graph, let's say I shift it here to this blue line, then my new interval length is now going to be between these two values right here. Those two values are no longer 0 and 2 pi, but they've been shifted by some amount. So we're going to set up an inequality to determine what this is now. The way that we do that is we take this inside value right here, the x minus pi over 3, and we set it greater than or equal to this left-hand boundary, which is a 0, less than or equal to the right-hand boundary, which is 2 pi. So what we're doing is we're creating an inequality equation, and I'm going to solve that inequality. To do that, I'm going to add pi over 3, add pi over 3, and add pi over 3 to all three sides. I'm going to bring down my inequality symbols, and I'm going to add at the same time, and I know that this would be pi over 3 here on the left-hand side, x in the middle, and then I have, this is going to be, what is 2 pi plus pi over 3? Well, if you don't remember how to add that fraction, let's just do it really fast. We're going to say 2 plus 1/3, and we're going to let the calculator do the fraction part for us. Math, frac, enter, enter. And we end up with 7/3. Okay? So I know that 2 pi plus pi over 3 is 7 pi over 3. So my new interval, in other words, one complete picture for sine, is now occurring between pi over 3 and 7 pi over 3. So that's what we've done first. Well, just like before, we want to divide this interval up into 4 parts. Okay? We're going to divide this interval up into 4 parts. Well, in order to do that, I have to know what is the length of this interval. So that becomes a subtraction problem. So I'm going to take 7 pi over 3 minus pi over 3, and I end up with, if you'll remember common denominators, I can just subtract the numerators. So I have 7 minus 1, which would be 6 pi over 3. And 6 pi over 3 reduces to be 2 pi. So I know that the length of my interval, in other words, the length or the distance would be 2 pi here, and I need to divide 2 pi into fourths. Okay, so I'm going to divide this, because I'm dividing it into fourths, we're going to divide by fourths here, and we end up figuring out that each fourth is going to be 2/4, so 2 pi over 4, which reduces to be pi over 2. So each part of my interval is going to increment by pi over 2. That's what we just determined. So we're going to take that, and we're going to come down here, and we're going to make our table. Now remember, the table comes from the x values of my interval length. Okay, that's what we're really creating. Remember also from up here, we know that my interval is now between pi over 3 and 7 pi over 3. So on this left-hand side, I'm going to write it as pi over 3. And then on the right-hand side, I'm going to write it as 7 pi over 3. And each time I move to these next columns, I'm going to add pi over 2. Okay, so we can use our calculator to do this really quickly. So this is really going to be pi over 3 plus what I already determined pi over 2 to be. When we add those two numbers together, you get 5 pi over 6. We're going to come back and we're going to take 5 pi over 6 and add pi over 2. You end up with 4 pi over 3. And then finally we take 4 pi over 3, add pi over 2, and we end up with 11 pi over 6. Oops, let me go back with my color. 11 pi over 6. So just to remember, this first number and this last number here, we got when we shifted my interval. Okay, so that gave me the first and the last number. Now, we took the difference of those two values and found out that the difference between them is 2, but I need to break this up into 4 intervals, so I divided that 2 by 4, and I got pi over 2. So that tells me that each time I move from one column or increment on my number line, every time I move to the next section, it's going to be by pi over 2. So I'm going to add pi over 2 to each of these values. All right, so here we have the x values for my graph. And in order to complete the table, we're then going to evaluate the function. Now let's copy the function down here. The function, remember, was y is equal to the sine of x minus pi over 3. So when we do the table method, we're going to come in and I'm going to evaluate what's inside of the parentheses, the x minus pi over 3, for each one of these headings. So that looks like pi over 3 minus pi over 3, which is 0. Then we do it again. 5 pi over 6 minus pi over 3, which is pi over 2. Okay? Now if you can't do that in your head, let me just show you one quick time as a reminder for how we do that in the calculator. This is really, we are going to ask the calculator to subtract 5/6 and 1/3. Okay, we're going to remove the pi symbol, subtract the fractions, and then we stick the pi symbol back on. So I'm only going to do this once just to remind you. 5/6 minus 1/3, math frac, enter. And sure enough, it's 1/2 or pi over 2. Okay, so we're going to keep going here. And I'm going to say 4 pi over 3 minus pi thirds, and we end up with pi. When I subtract the next value, I get 3 pi over 2. And finally, I end up with 2 pi. So I evaluated the inside of the function at each of these x-intercepts up here. The second part of this table method says now I'm going to take the sine of whatever I just calculated up here. So in other words, the sine of 0, which is 0, the sine of pi over 2, which is 1, the sine of pi, 0, sine of 3 pi over 2 is -1, and the sine of 2 pi, which is 0. Finally, the last part of this tells us what the ordered pairs are. In other words, the x and the y values if I were to plot these points. So this point comes from pi over 3, 0. So the x value is pi over 3, the y value is 0. So I have a point here. The next ordered pair would be 5 pi over 6 and 1. 4 pi over 3 and 0. 4 pi over 3 and 0. 11 pi over 6 and -1. And finally 7 pi over 3 and 0. So I can come in and I can graph these 5 points right here to finish up this drawing. So we come in, we draw the graph. I know that the y values that I'm going to end up going to are both positive and -1. And I'm going to mark off my x values with all of these x coordinates. So I'm going to start over here at about pi over 3. Then I have 7 pi over 3. In the middle I have 4 pi over 3. Then I have 5 pi over 6, followed by 11 pi over 6. So again, to graph this, we're going to come in and we're going to put a point here at pi over 3, 0, 5 pi over 6 and 1, 4 pi over 3, 0, 11 pi over 6, and 7 pi over 3, 0. And you can see that when I connect this curve, that I have indeed drawn one period for the sine function. Okay? So that's using the table method for graphing this horizontal translation. Let's look at one other method to be able to do that with. We're going to look at using just translation and what we know about those shifts to be able to graph this function one more time. So let's take out what we know. Okay, I'm going to start by writing that down. Number one, what do I know? I know the amplitude of this function is 1. What else do I know? The second thing I know is that b is 1, and therefore the period, which was 2 pi over b, is really just 2 pi, giving me an interval between 0 and 2 pi. Now I'm going to take this interval and I'm going to break it up first, right away. We know that this breaks up into 0 and 2 pi. I know halfway in between 0 and 2 is going to be pi. Halfway in between 0 and pi is pi over 2. And I can go back and ask myself, well, how did I go from 0 to pi over 2? It's adding 1/2. It's incrementing by 1/2. So if I add 1/2 here and 1/2 here, then I'm going to add 1/2 to this, and I get 3 pi over 2. The next thing we need to recognize is we have a phase shift. That's what this value is inside of here. That tells me that I'm going to be moving in the direction opposite of this symbol. So I'm going to be, instead of subtracting pi over 3, I'm going to be adding pi over 3 to each of these interval values I just made up. So we're going to come in and we're going to say plus pi over 3 to all 5 numbers. We're going to add those straight down, and we can see that when we add these up, we end up with pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. So if I know what the amplitude is, I know what the intervals are, and I don't have anything else to really deal with. The period was still this 2 pi. We're going to come down here and we're going to draw the function. So rather quickly, since I know the amplitude was 1, I just come in here and put negative and positive 1. I mark off the x-axis with these values up here. I know you're doing this yourself on your paper as well. And now we're going to graph the function. We know sine always starts on the x-axis. Then it moves high, comes back to the x-axis, moves low, comes back to the x-axis, and we quickly drew the sine function using translations. Well, let's practice that again. This time we're going to graph 3 cosine of x plus pi over 4, only I'm not going to do both methods. From now on, I'm only going to do the translation method. So I'm going to come in and I'm going to identify the parts of this that tell me how to translate the function. The first thing I want to look at is the amplitude. The amplitude is that coefficient next to my trig value, trig function, so I know that the amplitude would be 3. The second thing I want to look at is the period. The period of this function would still be 2 pi because I know cosine is 2 pi and I know b is 1 in this case. So if I know that the period is 2 pi, then I'm looking at an interval between 0 and 2 pi. I also know that I have a phase shift because I have this fraction being added, or I have a number being added inside of the parentheses. So I have a phase shift, which is going to do the opposite. So in other words, it's going to subtract pi over 4. So now that I know all of that information, I'm going to come over here and I'm going to write out my interval based on my period here. So I have 0 to pi. Halfway between that is pi, pi over 2, 3 pi over 2. So that's the original value. But I'm going to shift everything to the left by negative pi over 4. So I'm going to subtract negative pi over 4 to each of these values. So if I come through and start, I know the first value right here is going to be negative pi over 4. And I'm going to go through and I'm going to calculate the rest of these values. Okay, so I went through and I did the subtracting pi over 4 from each of these values, and I came up with a new set of x-intercepts occurring at these 5 spots right here. So if I know what the x-intercepts are, I know what the amplitude is, then I'm ready to graph it. So let's come down here. We're going to graph this function. We know we start over here at negative pi over 4. We'll just kind of break this up like this. Halfway in between, half and half. So I know that the left-hand side over here is going to be negative pi over 4, 5 pi over 4, and finally 7 pi over 4. I know I have an amplitude of 3, and so I need a 3 and a negative 3. And that's all I really need to know, and I'm ready to graph it, except the fact I need to remember that it's cosine. Cosine is always going to start at a maximum, so I have a maximum point over here. Almost missed that. I have a maximum point here. I'm going to cross at pi over 4. I have a minimum down here. I cross at 5 pi over 4, and I have a maximum over here at 7 pi over 4. So when I connect the curve, you can see I have a cosine function. So that doesn't take very long at all when we identify the individual parts and we break it down by translation. Let's look at one more together. And this time, we have a little bit more going on. For this graph, you can see I'm going to graph negative 2 cosine of 3x plus pi, and I'm going to do this over 2 periods. So let's just start identifying what we know. First of all, we need to recognize that we're going to have to factor out this 3 in order to identify what the period is of the function. So let's rewrite this as y equals negative 2 cosine of, factoring a 3 out of each of those numbers, we have 3 times x plus pi over 3. Now that we have it in the correct form, we can identify all the parts that we need. We're going to start with the amplitude. The amplitude is 2, but because it has a negative sign in front of it, it's flipped. So I'm going to put that on there so I don't forget. The next thing I know is b is equal to 3, so therefore the period, which is 2 pi over b, would be 2 pi over 3. So don't forget, I'm looking for an interval then between 0 and 2 pi over 3. And finally, I have a phase shift where I'm going to be doing the opposite, so I'm going to be subtracting pi over 3 from my interval that I'm going to divide up. So here I'm going to come over and I'm going to divide up this 0, 2 pi over 3, into my sections. So the way that I approach this is I take half, okay, so I'm looking at this interval here. What is half of 2/3? Well, that's 1/3, or pi over 3. So now I come in and I look at this section. What is half of 1/3? Well, that's pi over 6. So in other words, to get from 0 to pi over 6, we are incrementing by 1/6. So I'm going to add 1/6 to this right here, and you end up getting 3/6, which is actually pi over 2. So this interval between 0 and 2 pi over 3 breaks up like this, but I have a phase shift. So we're going to subtract pi over 3 from all 5 values. So I'm going to do that, and then I'm going to come back and write my values on here. So after subtracting this, you can see my new x-intercepts all are occurring right here. So I'm ready to graph the function. Coming down here, let's draw our graph out. I'm going to be on this side as well as this side. So I have a negative pi over 3, positive pi over 3. 0 is in the middle. I have negative pi over 6, positive pi over 6. I want to graph this for 2 periods, but I'm going to come back and I'm going to address that part in just a second. So let's go ahead and draw the dots first. I know the amplitude of this function is 2. So I'm going to need a 2 at the top and a negative 2 down here. I know that my function is flipped and that I'm graphing cosine. Cosine starts on the it starts high, it starts at the maximum normally, but because it's flipped, we're going to come down here and we're going to drop it down here. So I start here, cross at the axis, move to this, cross at the axis, and I end down here. That's one complete cosine picture. I need some more dots though, don't I? So I'm going to come back and I'm going to finish marking off my graph so that I can add some more dots to this. I know that from this dot right here, from this ending point in where I just stopped, I would normally come back and cross with a dot there. Then I have a high point up there, so I need another dash right there. I'm going to cross again, and I'm going to finally need to end somewhere, so out here. So let's go put those dots in, because I know that they exist. So I cross, I come up here, I cross, I go down here. Well, now I just need to figure out what are the values of these extra lines that I added to my graph. So the values are going to be, remember we're incrementing by pi over 6. So each time I'm just going to be adding pi over 6. So when I add 1/6 to pi over 3, I get pi over 2. Adding another 6, I get 2 pi over 3. Add another 6, I get 5 pi over 6. And finally, I end with pi. So let's come back and let's connect the dots. And you can see that I have graphed this cosine function over 2 periods. Now, I continued my period on here moving in the positive direction. You could have continued yours moving in the negative direction. You can even split it up and you could put a half a period on the left and a half a period on the right. Either way, it doesn't matter as long as you continue and you recognize that this function would be continuous, so it would go on in both directions to infinity. So that's what we're going to cover in this video, was just the translation, the horizontal translation of our functions.